Hey, what's going on, guys? It's Mr. AC presenting you guys a topic of the unit circle. Now, before we get started, you might say, wait, why do I need to learn about these special circles? Well, believe it or not, calculus has a lot to do with a very particular circle called the unit circle. Now, we're going to get to that later. Don't worry about that. But I want you to just kind of, at least hopefully as we go through, understand where everything gets developed here. Now, before we start, in order to get to the unit circle, let's talk about things that we know about circles in general. Now, in math and geometry, and it's probably been a long time since you've done that, their circumference is if you measure, let's say you put a string and you measure the length around a circle completely like such, right? And we were to put it out, here's the length, and we got a ruler. If we were to measure this circumference and then we were to divide it by the diameter being basically from one point to another point of a circle, right? So as long as it's cutting this middle portion here, the diameter is basically one length to the other, right? Perfect, like such. If we take the circumference and we divide it by the diameter, we actually get a very special number, 3.146 blah blah blah. Now, this special number, we could do this with any perfect circle. You could take any circle that you find at home, measure the circumference, divide it by the diameter with a string, and you will always get 3.14. Now, in math, we decided to say, hey, you know what? Let's go ahead and give that special number a new symbol, and that's technically where pi came from. That's one of the situations where pi was derived from. So now that we have this information, we know circumference divided by diameter is equal to pi. We have this formula here, but we also know this in math, this entire length right here is the diameter, right? The entire length here is a diameter. Well, what is half of your diameter? Well, half of your diameter is your radius. And you might ask yourself, how many radiuses do you have in one diameter? Well, two, right? We have half a radius here, half a radius here. So now we can actually write this as circumference divided by 2r, because two radiuses, right, added together give you a diameter is equal to pi. So let me go ahead and write that out like such. And what we're going to do now is we're just going to multiply 2r to both sides like such. And what we're going to get, let me put it up here, is we're going to get the circumference is equal to, and I'm just going to reorganize it, 2 pi r. Okay, there it is. So now we have that the circumference of any circle can be figured out by doing 2 times pi times the radius. So for example, let's say I have a circle with a radius of 3 centimeters. Okay, 3 centimeters. So we're going to get circumference is equal to 2 times pi times 3 centimeters. We're going to get 6 times pi. Let's say pi is 3.14, around 18-ish centimeters. So we can use this formula to figure out the circumference of any circle that we want, which is really advantageous for us. And that's why circles come into play. And we'll talk about a very special one in a moment. So to recap, to just kind of rehash what we learned here, we basically got this taken care of. And we can use this formula to find the circumference of any circle that we want, which is pretty nice, because now if we have a big old circle, we don't have to measure the entire circle, which if you try doing with a string, it's very annoying. You can just take the radius and then just go ahead and get the radius, plug it into the formula, and you can get your circumference, the length of the outer shell of that circle. So that is an introduction, my friends, to our circumference formula, where it comes from, and then where it comes into play. We'll talk a little bit more about something called the unit circle in our next video.